modify bit is useful. We're going to see some algorithms later on in deciding what gets offloaded. If something hasn't been modified in a while, and we already have a copy of that thing on the secondary storage device, then there's no need to write it out to the secondary storage device in order to remove it from main memory. This is very useful for code pages, pages that store the code, because that never changes. So if we had previously written out a copy of this page onto the secondary storage device, and we now want to steal that frame, we can actually steal the frame without doing any write operations because the copy is already on the secondary storage device. The hardware memory management unit will at some point encounter a page that the process wants, but it's not in main memory, and what we do is we call that a page fault. When a page fault occurs, the CPU switches to running the operating system. It's effectively an interrupt. It's the same concept as an interrupt. When a page fault occurs, the operating system switches to handling the page fault algorithm, and the algorithm says, well, what page was being requested, and then we'll put in a request to the I/O device to recover that page, store it into a frame, and then go back to running that process again. Of course, that operation takes some time, so in the interim, the CPU is probably going to be allocated to a different process, one that's ready and has all of its stuff in main memory and can go. As far as the programmer is concerned, there's huge benefits to virtual memory because the programmer can actually use more of memory than exists. In today's environment, we might have 8 gigabytes of main memory, but let's say we need 16 gigabytes of main memory. We can still do that. The operating system can emulate the fact that it has 16 gigabytes of main memory when in fact it doesn't. Because of the conversion between logical addressing and physical addressing, we can remove unused pages and load new pages from the secondary storage device or from somewhere else and make a simulation of having larger than total number of main memory. For the longest time, we had a 32-bit system in which main memory is perceived to be 4 gigabytes. And this goes back to the days when systems really only had 8 megabytes. So we might have a simulation of 4 gigs of main memory, when in fact main memory is only 8 megabytes large. So we can recognize a much larger capability from the